Okay, well, let's look at some more simplifying with radical notation and exponential notation. All right? So here to start off with, we've got 7 to the 1/3 times 7 to the 4/3. And hopefully we remember that x squared times x cubed. What do we do in this case? Well, when we're multiplying like bases, we add the exponents. So this will be 7 to the 1/3 plus 4/3, which is going to be 7 to the 5/3. All right? Same thing here. Now, I really want to view this as 2 to the 1/4 times 8 to the 1/4, and there is a property that says if these are the same, then we can go ahead and we can multiply this, and so that's going to be 16 to the 1/4 power. All right? That's only if these exponents are exactly the same, though. Oh, what do we got here? Well, again, I'm going to put these in exponential notation. 4th root is to the 1/4 power. And now what do we do with exponents? Well, don't we subtract exponents? And so 1 minus 1/4 is actually 3/4. And in this case, when you've got an exponent outside of another exponent, now we're multiplying the exponents together. So the 3/2 times 2 over 1, that's going to be 3. That's going to be to the 6 over 2 power, 3 to the 3rd, which is going to be 27. Okay? So we're using the laws of exponents here. It's just that our exponents now happen to be fractions. That's how we work with those. All right? And now we can do the same thing with variables. Base is the same. This is going to be 5/3 plus 4/3. That's x to the 9/3 power, which is x cubed. Here, now remember, we've got to put this to both the top and the bottom, both the numerator and the denominator. We've got to multiply, so that's going to be x to the 2/3 over 27 to the 1/3, and that means a cube root. That's x to the 2/3 over 3, because the cube root of 27 is 3. This is going to be a simple subtraction problem, because we've got on top, one on bottom, and we're going to get x to the 3/5. And then this is one where we're going to have to multiply together. What happens, this is like a 1 radical 2 times a 3 radical 2. Multiply the whole numbers, multiply the radicals. Hey, radical 2 times radical 2 is radical 4, but what's the square root of 4? Oh, that's really a 2, so that's 3 times 2, and that gives you 6. Okay? Now then, what if we're adding? Well, you can only add if we have like terms, right? So you can't add 5x plus 3y. But you can add 5x plus 3x. That would be 8x. So if we've got 6 cube root of 5 plus 2 cube root of 5s, the cube root of 5s end up being like x's here. And so 6 of them plus 2 more of them is going to give you 8 cube root of 5. Okay? So we can treat radicals kind of like variables when we're looking at like terms. So when I look here, and initially the radicals are not the same, are they? This is a radical 5, this is a radical 45. Well, but we're going to have to go back and remember how to simplify radicals. This radical is not simplified because I know that 9 times 5 is 45, and 9 is a perfect square. So radical 45 is the same thing as 3 radical 5. And so now I do have like terms, and I get an answer of 2 radical 5, because 5 minus 3 is 2. Okay? So you're going to have to be able to simplify radicals in some of these problems. Oh, not done yet. Okay, here's the last one. 2 cube root of 27. Well, 27 is what? 9 times 3. And what's the square root of 9? Well, that's 3. So 2 times 3 is 6 radical 3. Okay? Over here, 48, well, isn't that 16 times 3? and the square root of 16 is 4, so that's 12 radical 3. And so now I have like radicals, 6 radical 3 minus 12 radical 3. That's going to give us negative 6 radical 3. All right? And then here's simplifying a big, long radical with stuff underneath it. Well, when I do these kind of problems, I'm going to break everything up into 2 radicals. And I'm going to call this the perfect side. And I'm going to call this the non-perfect side. Can you take the fourth root of 3? You cannot. And so that's not a perfect fourth, all right? So I'm putting the 3 over there. Can you take the fourth root of 7? Well, no, but you can break up x to the 7th is the same thing as x to the 4th times x to the 3rd, isn't it? And you can take the fourth root of x to the 4th. And so I'm going to put an x to the 4th underneath the perfect, and I'm going to put an x to the 3rd here. So what I'm basically doing, if this exponent is bigger than what we're taking the root of, then I'm going to break that many out and put the leftovers there. Here, for the y's, couldn't I get 8 y's, and then there'd be 1 left over, and that would be my 9? And then the z, well, there's not enough z's. It's got to be at least z to the 4th. I'm 1 short. And so the z cubed is non-perfect. And then you just got to ask yourself, what's the fourth root of x to the 4th? X. What's the fourth root of y squared? Y to the 8th. It's y squared. And then you can't mess with these things. And so that becomes your answer. Bring out your perfect stuff and then take the fourth root of it. Leave everything else underneath the fourth root radical in your final answer. All right? Hope that helps.